Okay, let's discuss some really strange galaxies. And specifically, we're going to be discussing a still kind of misunderstood type of galaxies that quite literally are changing our fundamental understanding of how the universe seems to be put together. And well, you can see one of them in this image right here. And yeah, there is really not much to see. And that's because, once again, we're going to be discussing something in regards to dark matter. But in this case, actually, galaxies that seem to have none of it. And so even though for decades the standard model of cosmology told us that dark matter is this invisible glue in the universe that seems to keep galaxies together, in the last few years, researchers have found something that basically does the opposite, or essentially galaxies that seem to lack this glue, yet are still galaxies and are galactic in shape. And so let's talk about several studies that, as always, you can find in the description, that in essence all focus on a somewhat similar concept of dark matter-free galaxies, or basically these unexplained unusual galaxies that we didn't even know existed until the first discovery in 2018. But I guess let's start with the problem first. So normally, in a regular galaxy, dark matter acts as a kind of a gravitational scaffold, allowing normal matter like gas, dust, and stars to clump together and to create various galactic shapes. In fact, we've always thought that small faint galaxies known as dwarf galaxies, and especially galaxies referred to as UDF or ultra-diffuse galaxies, may potentially be some of the most dark matter-enriched objects, containing hundreds of times more dark matter compared to stars and compared to what's expected from a regular galaxy. And while astronomers have found these UDFs highly enriched in dark matter, and we've discussed many of them in a lot of videos in the description. But as it turns out, nature always finds a way to surprise us, and in recent years astronomers identified a handful of galaxies that seem to be doing almost the opposite. They essentially appear to have almost no dark matter, even though technically they should have a lot of it. And so in this video we're going to do some updates about them, including a newly discovered and newly confirmed dark matter-free galaxy that was only recently described in February of 2026. But let's start with the obvious. By having these galaxies that contain no dark matter, this essentially provides us with a definitive proof that dark matter is real. In other words, the only reason these objects exist is because they seem to have none of it, whereas other galaxies seem to have a lot of it. And especially inside these ultra-diffuse galaxies, UDFs or UDGs for short. And basically these are galaxies that are barely visible to the most powerful telescopes and are practically invisible to a commercial telescope, which is why we only found them not so long ago. They essentially resemble these very faint, ghostly smudges, even though some of them are just as big as the Milky Way galaxy. But because they contain 100 to even 1,000 times less stars, they obviously produce almost no light. And so back in 2018, one of these galaxies, NGC 1052-DF2, the galaxy you see right here, essentially surprised everyone. And that's because here at first, astronomers expected that the stars are going to be moving relatively fast, mostly because this galaxy should be enriched in dark matter. But by measuring the motion of star clusters and individual stars, something astronomers refer to as velocity dispersion, they were actually shocked to discover that inside this massive halo, instead of moving at high speeds, stars were moving incredibly slow. At the exact speed, as a matter of fact, that we expect from an object that contains practically nothing except for stars and gas. And that goes against all theories of galactic formation. We don't expect this to exist at all, and in theory it should not be possible. In order to have a galaxy, it has to have a scaffold of dark matter first. And for a long while, actually several years, a lot of astronomers were very skeptical. As a matter of fact, we've discussed additional propositions, such as maybe we just miscalculated the distance, because if this was at a different distance, maybe everything suddenly makes sense. But follow-up after follow-up essentially confirmed the same. The distance was correct, the motion was correct, and this galaxy contained no dark matter. And moreover, not so long afterwards, relatively close to this, researchers also discovered DF4, or basically its neighbor. And just like that, we now had two galaxies with very similar properties and in a very similar location. And though surprising, this potentially provided a clue. Maybe something happened in this region that actually stripped dark matter, making these previously regular galaxies become like this. And so this was a pretty big breakthrough. Here astronomers discovered that galaxies are not just floating randomly in this case, but instead seem to be a part of a tight cluster of smaller galaxies very close to a famous galaxy referred to as NGC 1052. But even more importantly, at some point a lot of this started to make sense when scientists essentially realized that they also form a kind of a line. And they were also moving along this line, suggesting that they're all kind of related. And so basically here we had this very tight linear trail of galaxies, with some of them lacking dark matter, but some of them being normal. But since all of them were moving in a very coordinated way, they definitely had some kind of a relationship and potentially experienced something in the past that basically made them this way. Which brings us to this very recent study that was just released of the third galaxy missing dark matter along this line. And so yeah, now we have DF9. This was discovered using the Cosmic Web Imager in Hawaii, which was able to create an extremely accurate measurement of the star dispersal inside this object. And just like its neighbors DF2 and DF4, it seems to show very low dark matter presence because the stars are moving super slow. And that makes this the third confirmed member along the same line, which actually confirms another proposition from a few years back where scientists tried to explain all of this with something like this. Basically, a galactic passage or a galactic merger that stripped many of these objects of dark matter that resulted in a galaxy falling apart and some chunks forming regular galaxies, other chunks becoming just stars and gas. Or essentially this was some kind of a galactic interaction that possibly stripped some parts of the galaxy from dark matter completely, but left other objects untouched. And that means that a lot of this would now kind of make sense. But that's not all. We actually have another surprise from a completely different region that seems to involve something extremely similar. And so here we have a discovery from last year from the cluster referred to as Fornax, which means that it's definitely not some kind of a local anomaly or some kind of an unusual collision event, but instead seems to be maybe kind of common. This is where this most recent surprise comes in. And so here, another candidate, FCC 224, in a different part of the universe near the Fornax cluster, this is about 60 million light years away from us, is another ultra-diffuse galaxy that seems to share very similar fingerprints with the previously discussed objects. And specifically, it seems to contain an unusual system of star clusters, and specifically globular clusters, that seem to look a little bit different from what we usually expect in a normal galaxy like the Milky Way. And so in a normal galaxy, these clusters follow a very standard range of brightness that's usually very easy to predict. But in this galaxy, as well as previously discussed DF2, DF4, and DF9, star clusters seem to be remarkably bright or even overluminous. So basically they're producing way more brightness than they should, as if all of these galaxies use the same recipe to form their clusters. And so here, by measuring the motion of stars in this galaxy, it was also confirmed to be very low in dark matter and was basically almost exactly the same as these three other objects in a completely different part of the night skies. And so finding these objects in such different environments suggests that they're not just some kind of an anomaly, but instead seem to represent a completely new class of galaxies we obviously never knew existed. And much more recently, in just the last few days, one of the researchers studying this, Maria Buzo, has also discussed a potentially other object, FCC 240, which seems to be very, very similar to FCC 224, and surprisingly also located in the same region. And that actually suggests that maybe these objects come in pairs or triplets, because something very similar seems to result in their formation, with the leading theory explaining this as something referred to as the bullet dwarf collision. Essentially two regular dwarf galaxies full of dark matter and gas smashing into each other at very high velocities and producing something very different as a result. In this case, the dark matter, which doesn't interact with anything, basically just sails through and keeps going. This is actually what we observe in the famous bullet cluster. But because the gas is kind of sticky and does collide with stuff, when the gas clouds from two galaxies hit each other, they produce a lot of shock and reduce their velocity, stopping somewhere in the middle. And so here this stored gas eventually becomes compressed, which also triggers a massive star formation period that produces a lot of stars all at once, which potentially explains why these galaxies are so diffuse, and also why they seem to have these very strange bright star clusters that must have all formed at the same time. But also of course explains why there is no dark matter. And in this case it would also explain why they seem to move along a straight line. This would be basically the line of their collision. But right now there's just not enough evidence and not enough additional observations to definitively tell how this is formed. The only thing we know for sure is that many of these galaxies are indeed almost completely dark matter free and seem to contain partners that are very similar in many different properties. But at the same time, by finding these galaxies and by confirming their existence, we can almost definitively rule out a lot of alternative explanations, such as the now infamous Mond theory, the modified Newtonian dynamics, because Mond cannot possibly explain the existence of these galaxies and regular galaxies. And so the alternative theories of physics unfortunately fail if these galaxies are real. Or basically if dark matter was just some kind of a property of gravity or required the change of gravitational formula we use today, then every galaxy should have the same effects. But these ones don't. Unless, of course, dark matter was some kind of a difficult to find particle, which in this case makes a lot more sense. And so it has to be a tangible substance that can be physically separated from normal matter. We just don't really know what this matter is. But right now this is still very early research, and astronomers are continuously looking for more of these dark matter-free galaxies in order to establish if this is indeed some kind of a new class we've never considered. Luckily for us, the Vera Rubin Observatory is going to be perfect for this, so hopefully we'll get enough data soon for astronomers to basically find tens or even hundreds of these, which will provide us with enough data to explain their formation. And so as we find more and more of these, we'll hopefully be able to understand the recipe for creating galaxies, and more importantly, we'll hopefully be able to figure out what dark matter particles actually are. Although right now this is also a pretty good reminder that even our most solid theories, such as the ideas behind galactic formation, are still open to a lot of new data and new interpretations, and do require a little bit of reworking. So definitely quite a lot to do for astronomers and astrophysicists. But on that note, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.